Imagine a particle that if it stopped spinning, the entire universe would collapse. Here's the problem. It isn't actually spinning. In our everyday world, things make sense. Planets spin, wheels rotate, motion is visible and predictable. But deep inside the quantum world, those rules begin to fall apart. There, we encounter one of the strangest concepts in physics, quantum spin, a property so fundamental, yet so deeply misunderstood. We often imagine the atom like a tiny solar system, electrons orbiting a nucleus, nice and orderly. But that picture is wrong. Electrons don't move in neat circles. They don't even have precise positions. Instead, they exist as probabilities, a cloud of where they might be. And yet, despite not being solid objects, they somehow spin. Let's assume, for a moment, that the electron really is a tiny spinning sphere. If that were true, its surface would need to move faster than the speed of light. Not just a little faster, but many times faster. And according to Einstein's theory of relativity, that's impossible. So we're left with a paradox. How can something have spin without physically spinning? Back in 1925, two young physicists, Samuel Goudsmit and George Uhlenbeck, proposed a bold idea. What if the electron carries angular momentum, but not in the classical sense? Not because it's spinning like a cora, but because it possesses an intrinsic property. At first, the idea seemed absurd. Even leading scientists rejected it. But it worked. It explained patterns no other theory could. And slowly, the concept of spin became accepted. Here's the key insight. Quantum spin is not motion. It's not rotation in space. It's not something you could ever see. Instead, it's a built-in property of particles, like mass or charge. One way to imagine it is as a tiny arrow inside the electron, pointing in a specific direction. We call these directions spin up and spin down. But don't be fooled. This is just a model to help us think. In reality, spin exists beyond our everyday intuition. This strange property isn't just theoretical. It's the reason magnets work. It powers lasers. It defines how atoms bond together. Even the device you're watching this on depends on quantum spin. And today, scientists are building quantum computers that use spin as a fundamental unit of information. So something that sounds abstract is actually shaping our entire technological world. Quantum spin reminds us of something profound. Reality is not always what it seems. At the smallest scales, the universe doesn't follow our intuition. It follows deeper rules, stranger rules, and somehow those rules hold everything together. So the next time you hear the word spin, don't picture something вращается. Picture something far more mysterious, a property with no motion, a direction with no movement, a phenomenon that shouldn't exist, yet does. Because in the quantum world, the impossible is often real. Science made simple. If you enjoyed this video, don't forget to like, subscribe, and share it with someone curious about the universe.